Students, we are talking about the first one of the random access MAC sublayer protocols, and the name of the protocol that we are talking about is Aloha. Students, मैंने पिछले discussion में we actually spoke about how pure Aloha actually works, or how system different stations they transmit over a shared medium using pure Aloha. Students, मैंने आपको बताया था कि in this particular case we have got a back off time period, and every station, once it actually encounters a collision, it backs off and waits for a random amount of period before it retransmits again. Students, there is another method that we use out here to try to detect collisions or to try to avoid collisions, and that method is that after the maximum number of retransmissions, so after a certain number of retransmissions that's set in every Aloha system, every system must wait for an additional amount of period before it can transmit once again. Students, slide pe chalenge, and we'll look at the flow of things or transmission as it happens in the case of pure Aloha in this particular protocol. Students, as you can see on the slide, in this particular case, we are actually defining some particular terms or quantities first. And the first one that we are talking about is K, where K represents the number of attempts. Then you've got TP, which is the maximum propagation time. Then you've got T frame, which is the average transmission time of a frame. And then you've got TB, which is the back off time. It can be calculated by R multiplied by TP or R multiplied by T frame. And R is a probabilistic random number, and its value can be anywhere between 0 to 2 raised to the power K minus 1. और मैं आपको बताऊंगा कि K max जो है वो normally that we choose in this particular case is 15. 15 is the max number of attempts. So students, in this case, as you can see, our timeout period, that is equal to the maximum possible round trip propagation delay. And that maximum possible round trip propagation delay is twice the TP, is the maximum propagation time. So maximum propagation time is the time it takes for the station to reach from the two most widely separated stations, one station to the other. So students, in this particular case, as I told you, your timeout period which is what we are using here, that is equal to the maximum possible round trip propagation delay, and that is equal to twice your maximum propagation time. So that is equal to 2 TP. Students, within that 2 TP, if an acknowledgement is received once the frame is sent in the first attempt, K is equal to 0 is our first attempt, we have sent the frame, we wait for 2 into TP. If the acknowledgement is received, we just stop there because we have succeeded in sending our data. If the acknowledgement is not received, we go to the next attempt, and then in this particular case, if we fail, we abort. And if we are still not able to be successful, what we do is we choose our random value R, as I explained to you, 0 to 2 raised to the power K minus 1. We wait for a certain amount of TB or back off time, which is once again equal to R into TP or R into the frame transmission time, T frame, and then we start this whole sending the frame, the process again. It's a loop out there. So in this particular case, students, this decision point is that K is greater than K max in this particular case. Students, there are the range of this random number R that we defined, it increases with every particular time. And that leads us to our second concept that is related to Aloha, and that is of vulnerable time for a pure Aloha protocol. Students, the vulnerable time is defined here as the length of time in which there is a possibility of a collision. So students, on this slide, as you can see, station B, in this particular case, it starts sending its data at time T. Now students, the problem here is that station A, assume that station A has started to send its frame at T minus T frame as well. And then students, we have got another station C that starts to send a frame before T plus TFR again. So T plus TFR is the time when B, which started the transmission at time T, is going to finish or vacate this medium. अब स्टूडेंट्स T माइनस FR A ने अपनी ट्रांसमिशन जो है उसके बाद स्टार्ट कर दी थी, एंड देयरफॉर T माइनस FR एंड T आर ओवरलैपिंग हियर. And similarly, if C starts the transmission before this T plus FR, then they will collide here as well. So all three frames are going to be thrashed, all three frames are going to be garbled and will not receive anything from either of the three stations. And this particular case, students, your as you can see, your pure Aloha vulnerable time is, let's represent that by Vt, that is equal to twice the frame transmission time. That is our vulnerable time for pure Aloha, and this is the time that defines the efficiency of our protocol.